All right. Hello, everyone, and welcome to the stream. I hope everyone is doing well tonight. Good to see you guys. Penguin Operator over on the Twitch side, good to see you. Over on the YouTube side, Mika314, thanks for the welcome back. I appreciate that. Abel Rashid, good to see you as well. Welcome. So, last week and indeed the week before that, I did have to take off. Last week I had to travel for business, so that was sort of unavoidable. And the week before that, I had technical difficulties. So, yeah, it's been a bit since we've been here, but we're going to pick up and get back to work. So, I am feeling well, though. Thank you for asking. I do appreciate that. Yeah, all recharged and ready to go, at least for the most part, right? So, really appreciate you guys being here. All right. Oh, and before I get into what we're going to talk about tonight, I do want to just take a quick second to thank the supporters of the channel, starting with our elite partner, Javier Lazaron, followed by our partners, Gaboldi's Inc. and Matt Osgard. They are the highest tiers of subscription over on YouTube memberships and Patreon, followed by the list of supporters you see scrolling past the screen here. They are a combination of the other tiers of support over on YouTube memberships, Patreon, as well as Twitch subscriptions. So thank you all very much for that support. It's greatly appreciated. Helps me cover the cost of running this channel, things like software licenses, hosting fees, eventually assets, things of that nature, recurring costs. So it's greatly appreciated, and thank you for that. And of course, I would be in error if I didn't give a big shout out to you guys, the viewers, whether you're joining me here live on the YouTube side, the Twitch side, or if you're catching the VOD after the fact. Thank you guys very much for being here, because without you guys, this channel and this project would not exist. So appreciate you guys. Yes, it has been a little bit. I guess I missed 2 weeks in a row, so not great, but you know, it is what it is. Sometimes things come up in real life, and you just got to handle them, right? But thankfully, we are back up and running. Singy over on YouTube, good to see you as well. Hope you're doing well. Apotham, good to see you as well. Olex, hello. How's it going? I have been great. Thank you for asking. Yeah, I just had some business travel to do, you know, for work stuff. So, you know, I had to take a little bit of time off for that. But you know, we're back. And tonight's actually discussion is going to be a little bit different than all of the stuff that we've done this far, because I kind of am going to use it to pick a direction that I'm going to go as far as movement systems are concerned with the game. And I do want to kind of just talk over what some of the basic options are there. I should probably also start with what we currently kind of have in place. So I will go ahead and run the application really quickly. Oops, let me drag this down here so you guys can see it. So currently we have this sort of imperfect system implemented, which is basically a nav mesh system. And so basically what that means is we can move within the bounds of this white mesh that you see here. It's actually a three-dimensional mesh, right? So it's got height as well as space on the XY, or the XZ plane rather. And so we can run around that, and we are bound to the edges and so forth. And it works mostly okay. There are a few bugs and issues that I would need to work out with that. This is certainly one way that we can do it, right? Where we have a collection of these nav meshes that we're sort of putting into the world that we can then interact with and sort of have our movement constrained to this thusly. So this is one way that we can handle it. Of course, the nav mesh itself would be invisible in the final product. We would have it match up to any sort of static meshes or any other sort of in-world sort of environment in such a way where it would look like you're actually moving over that, but really you're moving over one of these. And you'd have several of those things in the world, and you would sort of do various context-sensitive things to sort of bounce in between them, or maybe we'd have a huge one that existed for the entire world. There's a few options there, right? So this is sort of the first thing that I sort of scaffolded together, and you know, it's got a few issues, things like getting stuck in corners, some triangles aren't traversable. You know, a few bugs need to be worked out. Nothing crazy, but you know, that is something to consider as sort of our first option, right? So that's our first option. And so what that looks like under the scene, or under the hood rather, is we essentially have geometry that looks you know, something like this, like where it's arbitrary geometry. It could be any sort of geometry that we have, and essentially that would need to be triangle geometry, right? So we'd wind up with something that looks like this when we break it down into triangles, and then we evaluate each one of those triangles as we move around. Looks like, what did we get? Looks like we got a raid. Oh, wow. The Code Drift raiding with a party of 27. Thank you so much for the raid. How are you doing? What did you get up to on stream? Thank you so much for the raid. I really appreciate that. Shout out to... There we go. The Code Drift. I believe I am following you already. I'll double check that. Yes, I am following you. What did you get up to on stream? Thank you so much again for the raid. Let's see. Let me catch up on chats. It looks like I've got some chats over here as well, so let me catch up on that in addition. Diamond, good to see you as well. I am doing well. Thank you for asking. Appreciate that. Welcome, Raiders. Okay, so what we actually just got started talking about what we're going to be looking at tonight. So just to give you guys a an overview of what we're discussing is actually, let me see. Got our big startup project out the door and did a bunch of stuff, or a bunch of fast follow work. Oh, that's awesome, the Code Drift. Sweet. I love to hear about stuff getting published. That's always a really awesome feeling, is to get that work out the door, right? So there's nothing better than that. Hopefully, before too much longer, we'll be in the same position. Although realistically, you know, we've got quite a ways to go as far as our project goes here. It was a stacked PR of horror. Yeah, I've had a few of those myself, especially one recently, which I should probably bring up as well. I guess before we get too much, should I do that now, or maybe I'll do it afterwards? No, let me do it now. So I did release 0.12, which has a whole bunch of fixes in it. So let's see. Let me actually... So here's the... I think this is the pull request. Yeah. So as you can see, we have a number of files that were changed in the pull request. And so there's a change log here of all the things that we did. I'm not going to go over all of this on stream, but I did go ahead and update or release 0.12 release, as we call it. And so that's just sort of been merged into the main branch now, and we have that. So we're going to be working on 0.13 going forward. And at some point, I'm probably going to be making installers and or a little bit of tooling around getting this on a brand new workstation, and maybe automating some of the installs of some of the dependencies, things like that. Hopefully in the next couple of versions, so that we can start kind of experimenting with that and ironing out some of those wrinkles.
Had like a 6-month break from coding due to IRL stuff, but excited to get back into my game and being able to watch coding stuff.
That's awesome, Diamond. Yeah, I do understand having to take a break from coding stuff. IRL, you know, obviously is super important. Sometimes you get things that get in the way of that. Me with my carpal tunnel surgery not too long ago. So I do understand that. I'm glad to have you back, though. Thank you so much for the 30 months of Tier 1. That means a heck of a lot to me. And thank you so much for that support. I really do appreciate it. And I'm glad to see you back. Let's see. Do you refactor your code often? When I'm doing project, I often find myself refactoring old code over and over. Sometimes, yes, but I try to only do it when necessary. I try not to just do it all the time, because it just wastes time if you get into it. You know, the refactor tractor is something you have to crank up every once in a while, but you don't want to overwork that thing, right? So, are you using Vulkan as a graphics API for this project? Yes, initially. I do have support for Direct 3D and Metal planned as well. All right, so anyways, I wanted to just sort of bring up this sort of discussion of 0.12 was released. I pushed that out earlier today, and so we're going to be working against 0.13 for everything going forward. Now, what we were talking about when the raid came in, and actually I'll re-bring up the application so that you guys can have a visual example of what we're discussing here. So in the application right now, we're talking about movement systems, and that is specifically player movement, right? So right now, what I've got is what I'm calling this sort of nav mesh sort of based movement system, where you move around on this mesh, which is visible now, which wouldn't be under normal circumstances, and you're sort of bound to the mesh, right? So if you try to exceed the edge of it, you just sort of slide along the edge, and so you're sort of moving along and taking the height data from this, and you're sort of bound to this mesh as you're moving around. And this is a decent system. It's a system that a lot of games use, particularly things like walking simulators and things like that, action RPGs. The God of War games use these, or something similar to this, for example. And so this is a decent system. I've sort of hacked into place, just kind of figuring out how I might want it to work, and this works fine, right? This is one method of movement that we could certainly do, and as I mentioned before, there are a couple of bugs with it, like you can get stuck on corners, for example. In some cases, and there are some things that need to be ironed out. There we are, we're stuck on that corner right there, and there are some triangles that aren't traversable for some reason on occasion. So there are some bugs we have to figure out, but this system does work, and it is a viable system. And essentially what this is it's a system where let me see. Here we go. It's a system where the nav mesh is broken down. Looks something like this, right? It's a triangular mesh that we can navigate around, and we can have multiples of these. So we can have, say another one over here that looks something like this, and we can actually have the player move back and forth between the two of them via some other sort of mechanism that either animates from one to the other, or maybe there's some sort of connecting ladder where the player gets kind of attached to some sort of linear path where they can kind of tween in between the two, and then while your movement is sort of assigned to one or the other, you can just kind of move around like that. And that's a perfectly acceptable system, and it may be the system we go with. But I wanted to kind of talk about a few alternatives and things that maybe we could take a look at in addition to this, or maybe using this as sort of its baseline. There are some disadvantages to this. So one of the disadvantages is in the actual, I shouldn't have closed this. I should probably leave this open. So one of the disadvantages is that we have to either author these meshes individually, or we can also have the problem of in a larger world where you've got a very large terrain or something like that, you've got to either somehow make a mesh that matches the terrain, or somehow sort of extract the data from the terrain, which is something we could do as well. But for something that's a vast open world, that could be a little bit of a challenge just using these things. So constraining to individual meshes like this can be a little bit a little bit of a challenge when it comes to something that is an open world, right? Because you're going to have a lot of them, and it really works best with smaller scenes that you sort of move in between. So that's another certainly another discussion that we can have. It's certainly by no means a disqualifying concern, but I think there's some other things that maybe we could use instead that might be a little bit more robust and work a little bit better. So we have that as one option. I'll just kind of leave this running over here in the meantime. And then there is a second option that I got thinking of sort of offline. And that is a system that is somewhat loosely based on some of the concepts about, if you've seen it, where Casey Muratori talked about the killing the walk monster. It's some of these concepts are based a little bit off of that. And so I wouldn't be doing exactly the same way that he's doing it because I don't think we need that per se. But essentially what that means is we would have essentially a grid system that we would have in the world. I hope you guys can actually see this. So this is not to scale or anything like that. I'm just going to kind of briefly put some points in here so that we can actually discuss how this movement system would work, right? And so what this would be we would essentially build on top of this system that uses this kind of geometry. And instead of having the requirement of being bound to this geometry directly, we would have something that allows us to very loosely construct some of our collision geometry. And we would essentially generate some sort of new geometry to be able to navigate around, right? And so in the simplest example here, I've got this sort of grid of points, right? And imagine that you're looking at this from top down, and essentially the idea here would be that we are essentially doing raycasts into the scene, into all different kinds of geometry, right? So, and we would say, are we hitting any sort of collision geometry of any kind, right? So we would sort of tag these in the scene somehow to say, hey, this is a collidable object. We want to register as a collidable object in the scene. And so what that would mean is for each one of these points along a grid, we would essentially have something that says, you know what, this one collides with geometry. I can zoom this in a little bit. So we could say, this one collides with geometry. Go ahead and get the height there. This one does, this one does, this one does, etc. Right? And so we would have all of these ones that would either say, yes, they do actually collide with some sort of nav mesh or collision geometry, or the opposite of that, which would be no, they don't, which would be these guys here, right? And what we would wind up with is we would have essentially a grid of points to move between. And so the way I was thinking about setting up this movement system is it wouldn't be quite as free and open as this, but we would have sort of a grid-based movement system where we could move in between cells, right? So we could move back and forth this way, or even maybe even this way, right? And so we would have all of these things where we could move in either direction in between the points, right? And so you would be able to, essentially when you go to move, if you're going to go ahead and move to the right, in this case, we would say, well, is that a collidable point? If it is, go ahead and perform the move. If it's not, then don't. And then maybe just, turn the character or something if we need to, if they're not facing the right direction. And so this would be a very simple way and a very quick way for us to be able to generate movable or movement geometry, but it would also provide us a way to have sort of a dynamically updating piece of geometry, right? So let's say that we had, for example, a blocking volume that was a door, right? So we had this blocking volume here, right? And this was a door that went, across that collision geometry that says essentially we can't pass through anything that's within here. And so what that would do is that would actually temporarily mean that these, whoops, wrong color there. That would temporarily mean that these are not passable, right? And so there we go. And so that would mean that these are not passable. So if you were standing here and you went to go right, you wouldn't be able to because this is blocked. However, when this gets removed, so too do the blocks, right? And we wouldn't have to essentially update this because we would just regenerate, this space sort of around wherever the player is every frame. That would be relatively cheap because we wouldn't have to do a whole bunch of raycasts. It would just be a handful, maybe a dozen or two raycasts into the scene per frame, which, if you've got a relatively small selection set, and we use something like a bounding volume hierarchy, which we already have, those queries would be relatively quick. And so we would be able to, have a grid-based movement based off of that. And the other thing that would allow us to do would be we could come in here and we could create multiple pieces of geometry that overlaid one another, right? So we could actually have another piece of geometry that maybe an artist comes in here and places like that, right? And that would mean that we could also come in here and we would have collectively all of these spaces that would be navigatable as well, right? And so it would make it really relatively quick to build in the world because we could do something like this. But also, we could also flag things like the terrain and say, hey, we want the terrain to be, navigable, I think is the word. And we could say, hey, we want the terrain to be included in this. And so we could actually, when we're doing our raycasts, we could say, well, if we don't have any sort of terrain, or we don't have any collision geometry here that's above the terrain, we could look for terrain and see if there's terrain there. And so if there were, a huge piece of terrain underneath of here, right, that has all of its terrain bits, right, then suddenly you would have all of these spaces would be navigable as well, just at a different height. And then you could basically do things like take a look at the difference in height from this one to this one and say, hey, if that puts the angle past a certain threshold, then maybe we don't allow navigation there. And that would prevent navigation both ways. And so we couldn't also be trapped in geometry that maybe we shouldn't be able to navigate to in the first place. So that's kind of one of the things that I got thinking about offline. I haven't implemented it before, so that's going to be a very interesting exercise if we decide to go that way. Let's see. So let me catch up on some of the questions because it looks like there are some questions here. Due to some IRL stuff on my end, I'm pretty much forced to get an actual job, so I joined my friend's startup, this time with projection that what I code is mine until release, since I'm not going through what happened to me last time again. From the sounds of it, Apotham, we've both been there in the past, because those aren't concerns that just come up if you've never been screwed with a project, so I understand where you're coming from on that, for sure. If I recall correctly, there is a method for navmesh where you could add properties to the terrain vertices, so you pre-compute viable spots. Yeah, so our terrain, actually, if I do wireframe mode here, let me turn off some of these other debug bits. So our terrain here actually conveniently already has the grid information that we would need. So technically speaking, if our terrain grid were to align with the grid that we're doing here, we wouldn't even have to necessarily raycast this, right? We could just grab the vertex information at that point in the terrain, and we already have code to do that. So, if our movement grid happened to align with the terrain, that is definitely something that we could very easily do. Now, something I'd like to point out is at least at the moment, the terrain squares are somewhat large. So I think they're maybe a little bit larger than what I have here on this collision mesh. So essentially what we're talking about is if we were to stick with that, the vertices would be as finite as the player movement would allow, right? Now we could very easily say we could split this into a quarter, right? Or shrink the terrain down to give it more resolution. I don't think that that's necessarily needed. But again, a raycast into the terrain would be stupidly cheap, and we wouldn't do a lot of them per frame anyway. So we could pre-compute it, or we could actually add sort of data to each one of these cells that would say, maybe what the tessellated cell might look like in terms of pulling vertice or vertex data from that, or height data is really all we would need there. And then the other bit that I was talking about before, where we had a height difference. Might be a little bit hard to see here, but if you're coming from this vertex here to drop down to the terrain, that's a pretty sharp drop. And so that might be an example of something that we might not allow you to pass from a vertex up here to a vertex down here, for example. Okay. How would you account for stuff that you can go above and beneath bridges and indoors? So there's a couple of ways that you could account for that. If we wanted to have, so the simplest system would essentially be, we would not allow that, right? We wouldn't have bridges. We wouldn't have more than one layer that you could walk over. And that's the way that sort of the old school games like Doom and stuff did it back in the day. I don't think we need to do that, because I think what I would do is just start the raycast probably at the player's height, or maybe just a skosh above. And then that would basically exclude everything overhead, and only include what's underneath. And then we would just essentially take the highest result. So if you had a situation where this blue geometry here was the bridge, and the player was standing at that bridge, technically the raycast would pick up the bridge and the terrain, but since the bridge is closer to where the actual player is, you would take that one instead. Hope that makes sense. Wouldn't having a point-based movement system mean that movement could feel like snapping between points rather than continuous and fluid? Yes. And that is a downfall of doing it this way, for sure. However, lots of games do this as well. So if you consider games like Path of Exile, where you're clicking to move, it's kind of bound that way anyways. It's just a really tight grid in their case, and we could do a tight grid as well. And so instead of moving around, let me switch back off wireframe mode. Are my keybounds broken when I switch back forth from the editor? I think they are. Crap. Okay. That's a bug I need to fix. I must have just introduced that one. Okay. So, let's see. What was I saying? So instead of moving around like this with the keyboard, right, which I'm not convinced is the right way to do it anyways. You would basically, your WASD would basically move you to the next available point on the grid. And so you would essentially be able to, essentially holding A would rotate your character this way and run this way. Holding D would rotate your character this way and then run this way, and continuously keep hitting spots along that grid until you stop. And then if you were to go at an angle, you would go, something like that. If you were to press, let's say, S and D at the same time, you would wind up going this way. That does mean that if you were to use pathfinding to get from A to B, that you might have situations where you do something like this, but it would realistically it wouldn't be just sort of square zigzag. It would I would also take in catty corner, right? So you'd probably do something in order to dodge, in order to go around here, right? Like, let's say I clicked here, you would probably do something like move this way, then move this way, then move this way. And so, yes, it would feel a little bit confined to a grid. I think the smaller you make that grid, the better off you'll be. So we'd kind of have to feel that out. Oh, right. You're talking about the raycast at roughly the player head height. Yeah, okay. Yep. Maybe do layers of raycast in some fashion. I don't think so. I don't think we're ever going to be teleporting to higher layers, right? So I think if we were to start the raycast at the player's head, I think that would be sufficient. You can also do things like some terrain is non-navigable, but can be navigated by projectiles, for example, so you can be attacked over cliffs and stuff. True, yeah. So what I would consider non-navigable, and I'm going to actually step into the editor here again for a moment, is so a bit of terrain like what we have here, where this is a hill that goes up, that would be fine. But if we had a drop off like this, I would consider that non-navigable. And that kind of drop off would kind of automatically be covered by this system, just because of the difference between the height of this point and the height of the next point on the grid. We would essentially determine what that height difference would need to be to come out to a certain angle to say we don't want to be able to traverse over that. And so that would essentially mark that as non-traversable, and then you wouldn't be able to go up or down that, right? And then maybe in terms of traversing, we have different rules as far as that goes for different types of enemies. So if it's a flying enemy, then the flying enemy would be able to go over that no problem. Versus a typical ground enemy or player would be restricted by that. So we'd have different sets of rules in terms of how that would be navigable. And then also that would mean we could also set rules. So we could also do a quick check on water depth, right? So we have, let me turn this debug stuff off. So we have our water plane here, right? So we might say, well, we can walk up right up to the shore here, or maybe even into the shallow water a little bit. But if it goes beyond a certain depth, we don't allow it at all. Is that search in P movement? I'm really bad with terminology of this stuff, so I'm going to have to look up what that is, because I am terrible with names of stuff. And Google might actually be useless because it's talking about activewear, which is totally not what I'm looking for. So that's good. I'm glad Google's decided to be useful there. So you might be correct, you might not be correct. I'm not sure. Also, for top-down game, you don't encounter stuff like multi-layer collision, navigation or collisions. Path of Exile even has their collisions to essentially be a circle on the floor, not a 3D collision. Yeah, and that's the thing. Like, as far as collisions would go, like collisions with maybe other entities, I think we'd probably keep it simple, right? So if there's an entity here, right, we would probably say, well, we don't want to allow the player to move there. Or allow the player to move through the enemy, right? But an enemy could move through an enemy, right? So if we have an enemy, I don't know, here and here, and we wanted to say, well, this enemy wants to go over here, that would be a valid move, right? But if the player, which I guess will represent as brown, if the player is here, actually, let me use a better example. If the player is here, right, then we would say for the player to move here is not a valid move, right? So the player could also move here, but in order for the player to move here, he'd have to go up here and then down this way, right? So he'd have to sort of go around that. So, if we had another player character here, we could have a rule in there that says, well, okay, since these are the sort of the same class, then the player could move here just fine. And I think that's a perfectly valid way of handling that kind of movement. That way you never get screwed by, having some sort of skinny doorway somewhere and an NPC is standing in that doorway and you get stuck in the room because of it. So it kind of kills two birds with one stone there. Lost about 2 years of work among other things. I'm currently waiting to go to court, which is going to take years. It's a mess. Oof. Been there and done that, my friend. It's not fun at all. I can sympathize. Yeah. You found... Yeah, so this is the article that I was referring to. Well, actually, technically, it was Casey's killing of this, right? So he replaced this. So what I'm suggesting is actually not this or the replacement system he came up with. But some of the concepts here are based off of what he's talking about. How are you thinking about obstacles like fences that are very thin and their top-down projection? Forget how Casey addressed those. So, what I was thinking for that is there's a couple ways you would accomplish that. So let's say you had a fence. I really wish they'd give me access to more colors, but I don't. Can I do it? Yeah, I guess there are more colors. Okay. Let's go with, well, all these colors kind of suck. Right. Let's go with that color. So let's say we have a fence that is running along here, right? And it's just a very thin fence, right? I would not try to use I would not mark this as something that should be checked by the raycasting system, right? What I would do is I would take a blocking volume and surround the fence with it and just say, this is a place I do not want the player to be able to navigate. And then they would not be able to navigate that. And so these spaces, whoops, is it not going to allow me to, there we go. And so those spaces wouldn't be valid to move. Could just restrict your objects to be grid aligned. And I may do that, but doing it this way allows me to put arbitrary geometry wherever I want, right? So I can have, I can sort of have this, and then I think it's going to be super important for us to actually have rendered, either rendered geometry or rendered, at a minimum, rendered vertices as to where these things actually line up, so that as we're moving, we can actually see what's going on. which is not that restricting if your grid is fine enough. Yeah, exactly. So that's, picking the granularity of the grid is going to be another thing. And so blocking volume would essentially be in the same or a similar category as a navigation mesh, right? So blocking volume doesn't have to be square. We could have something that says, you know what? I actually don't want to allow navigation for, whoops, wrong tool there. I actually don't want to allow navigation for this space. Just yet, right? And so we could have something that looks like that. And so I use the term volume, but really it's just kind of another, oops. There's a couple things it could be, right? So yeah, we'd have to think about that. And also, it would also support, you would also have, even if we did stick with just squares, like there's rectangles, right? We could also have something that comes in here and is rotated to give the same effect, right? And that would make all of these non-navigable. Let me see. Let me catch up on the other side here. Did we figure out the hot reload crash? Yes. The hot reload crash was caused by me stupidly statically linking the library as well as dynamically loading it at the same time. And I'm surprised it even worked without crashing, to be honest. So I fixed that and it fixed the hot reload crash. Let's see. What do you think about Box 3D? So I'm going to get into that in a minute. You might have noticed the tab I have open there, so we'll touch on that in a second. Let's see. Hello, love the Kohi streams. Brazilian. I'm a Brazilian building a C OpenGL game engine with a nuclear-based editor. Editor's been the biggest headache so far. What do you mean by nuclear-based editor? Is that a library of some sort I'm not familiar with? C's been driving me crazy. I feel like the need to go back to the fundamentals. Any book recommendations on programming fundamentals? Problem solving, data structures, algorithms in C. Also, what's your plan for advanced physics in Kohi? Since it's written in C, most physics engines. Okay, so I'll come back to that too. So first and foremost, if you don't have this book, it's a must read. It's the C programming language. This is what everybody refers to as KNR, right? So Brian Kerningham and Dennis Ritchie. This is a must-read book. It's not a very thick book, right? But it's a must-read. If you don't have that, that's the first place to start, for sure. As far as data structures and algorithms go, I normally don't necessarily recommend picking up like a huge book full of them, because most of the time you're not going to wind up using 90% of them, right? You'll want to learn things like depth first and breadth first search and things like that, some of the simpler ones. But you're not going to want to sit there and study data structures and algorithms for months on end, because most of it you're not going to wind up using, right? Get a cursory knowledge of it, but I wouldn't spend tons and tons of time doing it. Kind of research the most common ones and just use them as you need, and look them up as you need them. If you read somewhere it's like, oh, I would do it this way, then go look up what that thing is. Like I said, I would maybe get a handle on some of the most common data structures and algorithms, but I wouldn't dedicate crap tons of time towards it. From like, good to see you. How's it going? Good to see you. It's been a while since you've seen Kohi running. Okay. Water and grass and the light looks amazing. Well, yeah, it's come a long way, especially from where you are in the series, for sure. Any opinions on the no graphics API article? I still have it on my to-do list to read. And I've only gotten a couple paragraphs into it, and I keep getting interrupted. So I do need to finish reading that article. I know which one you're talking about. I need to finish reading it. Okay. So this is kind of the second. This is kind of the second option as far as movement systems go. The third option, and chat sort of beat me to it a little bit because I kind of have this guy open, is there was a recently released Box 3D written by the same guy who did Box 2D. And so I was thinking about evaluating this because, like, this is one of the few instances where I would be like, you know what, I would actually use a library for this if I decided I need it, versus writing this stuff, all from scratch if I decide a physics or a full physics implementation is needed, or even a lightweight, rigid body physics simulation. I'm not convinced we're there yet, but I think having used Box 2D, I think if I were to go with a basic physics simulation, I would probably go this route. I need to evaluate it. It is recently released, so I don't know how stable it is. I don't know how performant it is, all that stuff. But I know Box 2D was, a pretty fantastic library, and I used the crap out of it over the years. So, if I would probably heavily look at Box 3D if I was thinking about going for a full physics simulation. I don't think I'm going to do that though. I think this is sort of the third available solution. The problem with going with a full physics solution like this is this is where it gets so that things are so open that it's very easy to create bugs, very easy to create bits of terrain that you can fall into and can't get back out of, and various ways to soft lock the game and things like that. And I don't think this is the right solution because of that. I don't think this game needs a full physics simulation, but if we were to go that route, I would probably look here or maybe Bullet or Jolt or something like that. I probably, would just use a pre-existing solution and make it a Kohi plugin. I'm not really leaning towards this just yet. I was looking at it, but I don't know that this is the way that I would go with this or not. So, we have a rating party of 38. Hypnotic, how's it going, buddy? I haven't seen you in a bit, which is my own fault, really, because I haven't been online as much. But thank you so much for the raid. What did you get up to on stream? Let me give a shout out. If you're not following Hypnotic, do it. There's the shout out. So are you still working with Godot, or no, you're using Raylib now? Nice. Trying to figure out GLSL shaders with a Raylib triangle. Oh, so you're really in it now, huh? You're going lower level then. Still making games with Godot while learning Raylib. That's fair enough. That's not a bad strategy at all. That is a solid way to go. Well, welcome, readers. Let's see. I have Jolt working with Raylib, so that's a plus. Awesome. Okay. We are actually just talking about movement systems and sort of the options that we have available to us, and I think, just kind of looking at all the various, I guess the three big options that are available to us, and I think I know the route that I'm going to go, and I think anybody that's been watching this probably also knows the route that we're going to go. So essentially, there are a couple of routes that we can go. So this is what I have right now, which is basically a nav mesh route where the player is allowed free movement within a three-dimensional mesh, and they're constrained to the movement of that mesh. This means, of course, that you have to author these meshes manually, which kind of sucks. You could extract them from geometry like this, but it's a very rigid system. You have to have something to sort of teleport you from one to the other, or animate you from one to the other. in order to be able to use them. So this is a system that lots of games, like walking simulators or even some action RPGs, some games like God of War use systems like this. And it's fine, but I don't think this is the system that we're going to wind up using because it's a little bit more error prone. It's not quite as locked down as I would like it, and it's not quite as flexible as I would like it either. And so that was sort of option number one. Option number two, we were talking about here, where we have some sort of system that's built on top of this nav mesh system, where instead it uses these as the basis to determine walkable points within a scene as determined by a raycast. So there's a raycast that comes from the player's head that goes straight down to see what's underneath. And it says, did this particular point in the grid hit a walkable area of a navigation mesh or terrain or something similar? If yes, then the player can traverse to that. If no, they can't. And your movement would essentially be, instead of free movement like this, you would essentially be moving from grid space to grid space, right? So like that. Although if you press and held the key, you would just keep going that way as long as there was traversable points in the grid. And so any sort of movement within those points is legal in terms of what direction you can go, even diagonally. And we started talking about other things, like you could have overlapping geometry, and that would allow us to very quickly and easily build out levels without having to build exact collision geometry in something like Blender. We could just kind of build it out or extract it from our 3D meshes even automatically within the world and use those to sort of generate this. So the idea is that you would essentially do raycasts at given intervals around the player, and you would use that to determine what is walkable and what isn't. And then you'd also have things like blocking volumes to determine, hey, there's a gate or something here that isn't currently available or that's blocking you from being able to walk this way, things like that. And so it would allow us to have this very flexible system, but also a system that could be very easy to change in runtime, because you would essentially be generating this every frame that you're moving, essentially. So yeah, that's a very, very quick explanation, because there's lots of other details in there that we were talking about. Different entity types versus, movement. So players and NPCs would be able to traverse through one another, but you couldn't traverse through an enemy, that kind of thing. Let's see, just can't get a shader to calculate the UV, so I can have a triangle drawn in by Raylab with a gradient color. Nice. Yeah, once you get that working, though, that's like the basis of getting everything else to work, so it's always nice to have that understanding. I've understood everything you've said, but I'm still confused. Me too, sometimes. Me too. Hello, is it possible to make a game without a game engine? I mean, yes, we're doing it. Technically I made the game engine, but yeah, that's what we're doing here. From Lake, good night. Have a good one. Thanks for showing up. Thanks for being here. Appreciate it. All right, so that was the second option, and then the third option, just to sort of to recap, was using something like the newly released Box 3D, which is by the same guy who wrote Box 2D. And if we wanted a full physics simulation, I think this is probably the way that would go. Physics is one of those areas I probably would not attempt to write that from scratch, even though I've written everything else in this engine from scratch. That is the one thing, I should say that, and reading asset formats for imports is probably the two things that I would not want to do from scratch. And so if I were to go the full physics simulation route, I would probably use something like this, or Jolt, or something along those lines. But I don't think I'm going to do that, because having something that's quite this open can lead to or be a massive vector for bugs when it comes to getting stuck in places and soft locking the game, things like that. So, Navy Me, hello, how's it going? Let's see. You can have a game without a game engine, especially if it's text-based like Zork, but then you would have a game engine for text-based games, not just a traditional engine. And a game engine for text-based games is called it's called a terminal. Right? Anyway, yeah, so of the three options, I am leaning towards this guy, which I don't actually have a name for it yet. So I probably ought to think about that. But essentially, the way that this would work is you would have your player. And actually, let me start a new area here. So let's say that this right here is our player, right, in the world. So essentially what we would do is, whoops, I didn't want to change the color of that, you dongus. I want to change the color of this. Okay, so the player would be starting at some point, right? And essentially the way that we would do this is we would raycast at individual points around the player, probably, cascading out or spiraling out something. Maybe we go, I don't know, 2 rows out at a time, right? And we do this whenever the player is about to move, I think. I don't know if we need... I suppose initially we can do this every frame. I don't think we need to do it every frame. Because if the player is not moving, there's no reason to sort of recalculate this. But my thought being is that we can essentially say, okay, from... You know what, let me change some of this geometry slightly just to make my example a little bit better, because this is not a great example in the way that it's currently configured. So we'll do something that looks more like this for our geometry, okay? And so essentially what we would do is we would perform all of these raycasts, right? And then of those raycasts that we perform, we would then come in here and say, well, so any of them that hit any sort of valid nav mesh or navigable geometry of some sort, we would go ahead and flag as, you can move here, right? And we'd sort of essentially keep a list of those, including the one the player's standing on, right? So that means that the player then at that point could move to any of these. And then we might have something like a volume in here that is just blocking us from moving somewhere, right? So we might have something like this that's like a gate, right? That says we don't want the player to be able to go past this particular gate, right? And I realize this is not to scale, and that's fine. We don't need it to be to scale, although I need it to. There we go. So if we have something in here like this, right? Let me see. Tweak that a little bit more. Obviously, this is not to scale, so there's issues there. So anything that collides with this guy now would essentially mean that there are a bunch of these that did qualify before that now don't. So we have that one doesn't qualify, that one doesn't qualify, this one doesn't qualify, and this one doesn't qualify, right? And so we'd still be able to move to any of these. And if we were over here, we'd be able to move to any of these, but since they're not connected, we would not be able to move to any of them, right? And we'd have to be very careful with how we position this, obviously. This one also would not be qualified. And so we would essentially, from that that list of vertices that are qualifying, we would then, come in here and eliminate, right? So all of these guys you can't move to, right? I'm not going to mark all of them. You guys kind of get the point. And so essentially what we would do next is we would say, okay, well, next we want to do a height check between any of these to say, well, if moving from one of them to the next one is going to be too big of a height difference, meaning they're going to like fall off a cliff or put us past a certain angle of movement, then we don't want to allow that, right? So that's another thing that we can do to sort of automatically eliminate it. And that means that they can't go over a cliff and get stuck, but they also can't traverse up the cliff, right? And all of this would essentially be rendered to the screen in real time so that we could actually have feedback and see exactly what's being done, right? And so if we have this grid finite enough, then moving between the individual cells should feel good enough, right? It's not going to be super smooth like some games you might expect, but you know, this is an action RPG. I think that's fine, right? Or she, how's it going, buddy? Thank you for stopping by. I appreciate that. Haven't seen you in a while. Hope you're doing well. I am doing well. Thank you for asking. Yeah, I just had I had some technical difficulties 2 weeks ago, and then last week I had to travel for business. So it's been a while since I've been able to get on. Let's see. Let me catch up over here. Do you think OpenGL with DSA could handle a small 3D world? I don't want to invest all of my time in something that doesn't work for my purpose. Started working with an RHI because Vulkan is the present. I mean, OpenGL can handle most things that Vulkan can handle just fine, obviously without hardware accelerated ray tracing, things like that. So it depends on what you're trying to do. OpenGL is deprecated, but it's not dead, right? So you still can very much use it. What type of BVH do you use, and for what are you using it for besides NavMesh? So I'm actually using it for object selection. So I actually use it in here. So we have a BVH in here for all entities that can be selected. And so I'm using it for selection here. And all of the red squares are the representations of the different nodes of the BVH, right? So we already have a BVH for object selection. If I go to entity mode, I can use this to select an object, right? This one's technically in front of that, so that's why that one gets selected. And that's what we use for wow, why is that? Oh, that's an interesting bug. Looks like I've got some work to do on my key maps, because it's switching both the mode and okay, that's actually pretty funny. Okay, but yeah, that's how we move objects and stuff, so I use it a lot for that. Okay, can't choose between OpenGL and Vulkan. I would say roll with whichever one you're more familiar with, honestly. Abstract it away from the rest of your engine, though, in a way where it doesn't matter, so that if you decide you want to switch over later, you can, and you don't have to rewrite your entire engine, just the renderer. Yeah, I mean, there's no reason you can't use OpenGL unless you're trying to use like super advanced stuff like hardware ray tracing. Okay. Maybe you can explain a bit more about the Kohi plugin system. Is it compiling everything as DLL and so load DLL/SO and loads them at runtime? Any idea how long it took you to get the basic version of it up? The basic version of it did not take very long at all. So essentially the way that plugins work is there are different types of plugins. So there's a renderer plugin, which is the Vulkan backend is a plugin. There's an audio plugin, so we have an OpenAL plugin for that. And essentially, Those just have a interface, so to speak, that must be met, which is a series of functions that need to be loaded dynamically whenever you do, DL open, DL sim, all that stuff. And then those function pointers are fed into a struct, and then that struct is what the front end of those systems uses to interact with. So that's really all there is to it. Is there's just the functions have to be named a certain thing so that the plugin system can say, hey, I'm looking for a function that's called this, and it grabs the right symbol and uses it. That's really all there is to it. It's not very complicated at all. Let's see. Any specific reason you went with a system like that? Which system are you referring to exactly? Let's see. Looking forward to sloped roofs making the code more complex. I don't think so, though. I mean, like, again, the raycasts are going to start basically with the player's head, right? So everything above the player is automatically excluded. And actually, we probably are going to have other ways of eliminating that anyway. Do you have any advice for finding a job nowadays? It seems like getting a job is so annoying now. Applied for a junior role that asked for 4 leak code hards in 2 hours. Here's the thing about that. It's been a long time since I was a junior starting out in this stuff, so take what I say with a grain of salt, right? Because there are a lot of companies that use leak code as sort of their filtering out mechanism. I don't think that that's right. I generally avoid places that use questions like that extensively, just because I found that it doesn't actually give me accurate results on who's a decent programmer and who's not. Just because you've memorized leak code problems doesn't mean you're going to be able to code much of anything when it comes to an actual production environment, right? So, I have mixed emotions on that, and I've been both on the hiring side as well as obviously the applying side. So, usually if it's some company that's going to be like, yeah, we have 6 rounds of interviews and you're going to be doing 4 sets of leak code problems per round of interviewing, I'll just be like, well, I'm not going to waste your time or mine. And I'll just look for a company that doesn't do that. That being said, I don't really have any interest in also working in large companies anymore. It's just not, I've been there and done that, and it generally just is not for me. It's not, blanket advice per se, but that's just kind of my feeling on it. The worst I applied for a job was 8 rounds of interviews and they ghosted me at the final round. See, that's the crap I'm talking about, right? Like, if there's that many, like, why are there that many rounds, right? 8 rounds is I would say borderline abusive, right? That's just totally not necessary. You don't need 8 rounds. I would say probably ideal is somewhere between 3 and 5. And the reason I say 3 and 5 is, if you're counting the initial HR call that you have as a round, then fine. Usually you have at least 2 coding rounds, and then you'll have, maybe a behavioral round at a minimum. So that's usually around 4 to 5. And I think that's reasonable. Anything over that, I start questioning things. Because they do this kind of stuff, right? Where it was like 8 rounds of interviews and then they ghost you, right? And you have no idea why. But yeah, professional advice, be patient, very patient. Yes. And frankly, know when to say, you know what, this isn't for me. And just keep looking, right? It is very annoying. The market out there is very annoying. For sure. It's very hard to find something that is fine-tuned for your set of skills, but also by the same time bear in mind that nobody is going to expect you to have 100% of the skills they list on the position, right? So just because they say you have to know these 6 frameworks, well, if you know 4 of the 6 frameworks and 2 of them, an alternate that has similar concepts or something like that, like, that's fine. Apply for the job anyways. The worst they can say is no. But just keep trying. Be more stubborn than they are, essentially. Feels like a humiliation ritual at this point. Yeah. And unfortunately for some interviewers, that's exactly what they love to do, right? I've certainly had people who I've interviewed with who, just love running people through the grinder because it gives them some sort of personal ego boost of some sort. And those are the interviews I'm just like, okay, I see what you're doing here. I'm done. And I walk away. Because generally speaking, you're not going to get that anyway. Those people are looking for someone to one-up them, and they're generally not the kind of person you want to work with anyway. So, I don't know. I know that's super, super general. But I don't want to get too specific because, like, my situation is not going to be the same as yours, right? What worked for me may not necessarily work for you because you and I are different people. We have different skill sets. So there's no one size fits all, and anybody that tells you that there is one size fits all is full of crap. To be honest, though, I'm not too focused on being a software engineer. Fine working on IT, just like being around computers. Then there's nothing wrong with that at all. There's a need for good IT people out there, for sure. What language are you using? C. Okay. See, I did use some of the plugin ideas in my current engines. Allows me to have both Vulkan and Direct3D12 rendering cooperatively for experiments. That's exactly the reason I designed this the way I did, because I'm going to have those as well. I just haven't gotten around to writing the other backends yet. For my experience, Vulkan is better. That might be the scale at which I operate. On old PCs, it might not work properly. That's true. What kind of hardware? So it depends on your requirements, I would say. Platform support and what features do you need, right? If you're making a game that looks like it could run on like PS3, do you really need Vulkan? Probably not, right? Like what features are you actually working with? You don't necessarily always need Vulkan, right? I did it here as a challenge, but not because I had to. Any advice on how to find motivation to work on your games when you feel a bit drained after work? That's a tough one. I struggle with that a lot. Streaming is one of them. Because I found that by forcing myself to have some sort of schedule, I really feel bad about backing out of that. So I don't do it all that often. Unless I have something in real life that comes up and I have to. But yeah, just putting yourself out there and saying, hey, I'm doing this thing, come follow along, can be a huge motivating factor to keep going. And also there's the sunk cost fallacy too. So once you get a certain way into the project, you don't really want to walk away from it because of all of the work that you put into it. So it took me 5 years to run into limitations with OpenGL. That's my point, right? Like, unless you're doing something crazy, like, you don't have to use Vulkan. Sad truth is where I live, no one needs C or even C++ programmers. I've been working with these languages since 2018. I can't have a job. No one gives a crap. Yeah, so that's, I mean, more than likely, if you find something like that, it's going to be remote, probably. I know my job is. Because finding something like that locally is probably just not going to happen. It's going to be remote, like I said. Okay. So, I think for me, motivation is to have the feeling of no 0 days. So even if there is no motivation, I just open up the code and do something for even 5 minutes somehow ends up working hours. Yes, that's a good point. And I actually lost track of what I was talking about. So that's another good thing to do, is to just constantly work on it. And I don't know, like have a physical calendar somewhere where you can like tick off the days that you've worked on it, and try to keep the longest streak that you can of those one after another. Because that's definitely a great way to do it. I did the same thing with language learning as well. So it's applicable to a lot of things, not just doing this stuff. Curious about your engine? So if you are curious about my engine, you can go there. That will take you here, and there is a link to the GitHub down here if you scroll on the page, and that will take you to the GitHub repo. The engine itself is free and open source. It is Apache 2.0 license, so that means you can use it for anything you want, commercial or private. Does not matter. All that I ask is that if you use it, you just say you used it. That's literally it. And so, yeah, there's a README here on how to get started with it. I've updated this recently to include a little bit more details on it. And then, of course, you know, the whole YouTube series that goes along with it, and all of the streams that go with all of its development. But yeah, that's that. So it's available there for you to use. There is a driver project called a testbed. That's the application that it ships with, that you can use to actually run it. This Shadows of Illumina is game code for the actual game that I'm using the engine for. This is not open source yet, but it is built on top of the open source engine. So after this game releases, anything that is in the game code, 2 years after the game goes live, I will be open sourcing the game as well. Okay. All right. I think I finally caught up on chat. Cool. So, what were we were talking about these different movement systems. I think it should be fairly obvious that the one I'm actually considering is this here, and I don't actually know. I don't have a name of what this is called. I don't even know how to refer to it. So what I'm going to do is I'm actually going to prototype this system in game code, and the reason I want to do that is because the game code is hot reloadable. And so we're going to build this out in game code. I'm going to wipe out what's here, which is essentially the logic that is here for this. I'm going to wipe this out. I think, you know, this was very experimental. It was fine. Maybe, I mean, I guess it's in the repo. If I want to open source it later or work it back into the engine somehow, I'll do that. But I don't think I'm going to keep this logic, right? So I think what we'll start looking into is how we want to actually architect this, and go from there. So there's a couple pieces to this that we're going to need. So we're going to need, obviously, I guess I really don't want to call it nav mesh geometry, which is kind of what we're calling it now, because that kind of gives it a different. Let's call this collision geometry. Right, so we need collision geometry. We need a raycast. We'll say a grid-based raycast system, right? So it's just going to be something that based around some position. Right, on the grid. So we're going to need, obviously, some sort of predefined grid of vertices. And so each vertex, we'll say each vertex will have. So we have... So traverse type, right, which is basically going to say We can walk on it. It's flyable, or essentially none, right? And these things will be, these will probably be actually flags, so they could be combined, right? And so the thought is here is that we'll do, things like the height check and bounding volume check just to determine what flags should be allowed and not allowed on each vertex, right? Obviously, we'll have a height. And then maybe, and this is a big maybe, we might have a list of linked do I want to say traversal? No, let's say a list of linked vertices, right? Just for ease of navigation, right? So we need a grid-based raycast system based around some position on the grid, right? So if our player position is here, we need to essentially radiate out from that and do raycasts there to figure out what's traversable. We need a grid-based movement system that moves the avatar correctly, right? And blocks as needed. So we need that. We need the concept of, actually, we should probably put up here blocking volumes. Under collision geometry, we should probably also put also get info from terrain if there is one, right? That kind of thing. Can make it so you only have one permission to the code after you can make it so you only have permission to get to the game code after 100%ing the game. Yeah, the problem with that is one person would 100% it and then just leak the code, right? Versus me actually waiting to open source it. I would have full control over when that code actually gets released. And then once it's out, it's out. Which I think would make it a little bit more special anyway. Dr. Elliott, good to see you. How's it going? Welcome. Good to see you as well. It has been a while. Maybe an entity ID in case the tile is linked to a dynamic entity. So we don't actually have to worry about that, right? So the whole idea of basically doing this calculation once a frame is because there is the possibility. So in this circumstance over here, this example, let's say that this particular blocking volume was in the next couple frames moved over here, right? Which would essentially mean that these are now no longer blocked, right? And we would just get that in that frame by moving this blocking volume. And so we don't have to tie it to the entity. We don't have to do any of that stuff. All we have to say is move this blocking volume, and all of a sudden that update automatically happens, and these become traversable because this thing has moved, because we're constantly recalculating that every frame. And that should be relatively fast. Thank you for the Prime, Dr. Elliott. I appreciate that. 10 months. I really appreciate that support. Thank you so much. This isn't baked data. No. So this would be generated. I'm thinking once a frame. I'm going to start off with once a frame. Where you're only talking, in this case, 25 raycasts a frame. I don't really think that's a big deal. I think there's going to be a lot of other things that are going to be bottlenecks besides that. So yeah, I'm not really worried about it. What happens if a tile changes to non-walkable solid on the player? So that's going to be something that we have to be careful to avoid, right? And that's going to be essentially design is going to prevent us from doing that. So we'll have to be sure that this blocking volume could never be moved while the player is standing on it, for example. Unless, and there's a couple of exceptions to this, we could also have some sort of other type of volume that says, well, if the player is also standing in front of this, where we go to block it, if the player is standing here when we move it here, it just kills the player, right? Or whatever is standing in it. Ideally, I think we can design the entire game without this really being an issue. The only place where we're really going to be doing this a lot anyways is like opening a door. And so even then, more often than not, we're not going to really be animated sliding it. We're probably just going to make it disappear, which is in a single frame. So I think that's going to be it, really. Good question, though. Will all the goblins on the goblin army use this system? Well, I don't know. Who's the goblin army? We have the dingus army here. So all the dingai will use the system. Now, I think what you're asking is, are the enemies going to use the system? And yes, the enemies are going to use the system. The NPCs are going to use the system. Everything will. I'm wondering why not use Box 2D for the collision resolving, still use the grid system for movements interaction. I suppose that's a valid thing, right? We could theoretically do that. But by constraining movement this way, we can also make other certain guarantees that we can't move into certain bits of geometry that we shouldn't be able to reach in the first place, and get stuck, right? So I think there's other guarantees that come with doing it this way that make it worth it. And I don't know, maybe we wind up switching away from this later. I don't know. We're going to try it and see how it works. Because we tried this to see how it works, and it's fine, but it just wasn't really what I was going for, right? And you could essentially use Box 2D to get this same effect from top down and then just extract the height from the mesh via raycast. That wouldn't be very hard to do at all. But I think having a system like this is going to be a lot more rigid, yes, but I think it's also going to prevent a lot more bugs. So, any recommendations for physics engines? Depends on the problem that you're trying to solve, I would say. There are some that work better than others. Licensing is also a thing that you have to bear in mind. It's not a one-size-fits-all answer. Box 3D just came out, so at some point I will be evaluating this, but I don't think I'm going to wind up using a full physics solution in this game. Maybe in the future. Okay, so I think, are there any, I'm trying to think of any exceptions. Where this might not be a great idea. I think one thing we need to think about is if the grid needs to be tight enough to make it feel sort of natural, right? So we don't want space between vertices to be like one vertex is here and then the next one you can move to is here, right? That's huge. Ideally it would be half or even a quarter of that, right? So like each one of these would probably move you like that far or something. Maybe a little bit farther than that, right? Like maybe from here to here. And then when you click to move, obviously it would just move you to the closest vertex that you clicked that's available. I've always run into issues when mixing non-grid movement player without a tick system like old school RuneScape with grid collision. Yeah, so that's going to be... So that's the other thing that this system sort of helps to get around a little bit, is we don't actually have collision here at all. All we are doing is saying, can this point be moved to, yes or no? We don't actually have any sort of collision, so we don't have to worry about sliding along edges. We don't have to worry about any of that kind of stuff. It's literally like, can we move to this spot, yes or no? And then either do it or don't. Grid system seems stable when looked at a single point in time. The vert nature of the grid being non-fractional and very binary doesn't mix well when time is thrown into the equation. But again, you'd have to design your whole game around that problem. Yes. So there's multiple things to figure out, right? So one thing that you would for sure run into is if you have point A and point B. Actually, let's split this into thirds, right? So if your player, if you're starting here, essentially, when you go to move, and you've decided I want to move to this particular point, while you're moving from here to here, there is nothing else you can do, right? This has to be sort of, it's almost like a database. It's got to be transactional, right? You have to say, I've committed to moving from this point to this point. And so until that is complete, there's nothing I can do. Once you get here, then essentially under the hood, you would take your representation. Whoops, why is that? Stop it. You would take your representation and move it here to say, this is where I am in the world. And then you could begin a sort of new transaction to move to this next one or to move here. And this concept doesn't change whether you're doing it just one at a time or whether you're saying, well, I am starting here and I want to move from here all the way down here. What this would be essentially is just a list of queued transactions, right? To say, well, first I want to move here, and then I want to move from there to here next, right? And so only when you get to a point where you can actually make a decision, right? So that would be the next decision point would be you could either go, north or go this way. Only when you actually get to this next place can you actually make that decision. So you could actually say, well, I'm moving here, and let's say when I get here, initially I said I wanted to go this way, but now I don't want to do that. Now I want to go north. There'd probably be some sort of little bit of a gradient in time, like this, right? That says, if you're within this, you can start making the move for the next transaction, right? And you can select whether you want to move this way or move this way, right? And if you keep in mind that these arrows are basically time, where you can't do any sort of movement or change of any kind within those, it should be fine. But again, we'll have to play with that to see exactly when we should allow those transactions to be committed and so forth. Let's see. Is your game inspired by Baldur's Gate 3, Diablo, or something else entirely? Curious what influenced its design. It's a little bit inspired by God, the name has escaped my mind. I've already said it. Path of Exile. Neverwinter Nights. It's kind of a mix between those two, I would say. Maybe Baldur's Gate 2. Kind of a mixture of those. But it's not going to be turn-based. It's going to be action RPG, right? You just need to be, your movement is going to be essentially grid-based, right? So if you, for example, let's say there is a bad guy up here. Why don't you just use the circle? Or I'll use a diamond, right? So there's a bad guy here, right? And let's say your player is here, right? You want to attack this bad guy. What you would essentially have to do, or actually, I guess we wouldn't need that. We would need this, right? You would need to be right next to that enemy in order to perform like a melee attack on them, right? So you would have to essentially move here, and then move. Why is it dragging the arrow with it? Stop doing that. Okay, so you would essentially have to move here and then move here, and then you could attack this enemy, right? And that's for melee. If you're doing some sort of ranged or magic attack, then as long as your distance between here and here is less than whatever that amount is, you could just shoot your lightning bolt or whatever straight across, and it'll reach. So not turn-based, but it will take a certain amount of time, obviously, for you to move here and here. I do plan on making the movement pretty quick, or relatively quick, or at least quick feeling, because the amount of space between these points is not going to be very large. So, we're talking like for this type of a scenario, it would probably be like, something like that. Very, very small movements. And you may not even have to be, I may not even make the attacks grid-based at all. I may make them just distance-based. So I haven't really decided that yet. But I think as long as the grid is fairly tight, it should be fine. How would you handle a thing pushing you? I wouldn't do that with this system. Something awkward from this is that dungeons will have the same length as walking the two orthogonal sides. Everything is in grid distance. Let me reread that. So, this is that diagonals will have the same length as... Oh, yeah, so you're talking if we walk this way, then technically you're thinking that you could traverse the dungeon quicker if you use back and forth angles, right? Because that can actually move you a little bit quicker. No, we would actually scale for that to make sure that the movement never exceeds your speed, right? Because this is a greater distance. You wouldn't want to have to move faster to get from here to here. It should actually take longer if you're moving from here to here than here to here. So we would calculate that in. Could move the player slower on diagonal, though, just go 40% slower. Or whatever it would wind up being, yeah. We don't move, or we don't base the movement speed off of the distance between points. The movement speed is the movement speed. I hope that makes sense. Okay. What the heck do we call this thing? I guess I don't need like a fancy name for it. I just need some way to reference it in code, right? I guess we just call it the aluminum movement system or something like that, right? Sure, that's fine. Don't need fanciness. Right, so I think this is going to be the next thing that we're going to implement. And I think probably the very first step of writing this is actually going to be, I'm just going to generate a grid of spaces that don't take height into account or don't have any of this blocking stuff, or it's just, it's going to be the simplest form of this, which is basically going to be just a grid that you can move around on that doesn't have any elevation changes or any of that stuff, so that we can actually get the movement feeling right between points first. And then we can sort of go back and generate movable versus not movable, or navigable versus not navigable, traversable, whatever we want to call it, based on all of this other stuff, right? So I think the absolute first step of this is going to be generate the grid of points and get movement working between those points, and then we can go from there. So with that in mind, let's go ahead and kill that. And I'm going to go into, let's see, should we put this in, I feel like we ought to put this in aluminum main. The only problem is, we do have the avatar system and the player avatar. We do have that. Okay, this is, I think, probably where we're going to... I think this is probably where we're going to work it in, at least the update code. So, I'm going to put a to-do in here. Or I guess I'll put a... Yeah, I'll put a to-do. So we're going to call this IMS, right? So we're going to say IMS, player movement and control updates for movement grid. And all of this stuff is probably, well, a lot of this stuff is maybe going to go, no, maybe not actually. This is all actually setting the camera and stuff. So actually that's probably fine just like it is. Okay, so we have that. That's the avatar for that. Oh, I think what we might have done, I think we were building the nav mesh stuff into the player avatar, which was totally not the right place to do it, and I think I knew that in advance. So in player avatar, we have all kinds of crap in here that does not belong in here. And a good portion of it is in here. This is all the nav mesh stuff. So I'm going to put to-do IMS. And for this, actually, I don't know if we need anything here. If anything should be here or should be driven by higher game logic interacting with the grid system. I'm thinking probably a lot of this is going to go away, actually, which is good. We're going to have to rework the control scheme to actually move one grid piece at a time. I suppose we actually need to set up the grid somewhere and think about how we're going to represent the grid. And that's probably going to wind up being an aluminum main for now. Probably right in the application types, I'm thinking. So in the application states, I really need to get some of this UI crap out of here too. Should we put it here or put it in the game state? I think we can actually, let's just put it in the application state for now, I guess. So we need something that we're going to call the movement grid. So I guess we'll put that here. And we'll call it movement grid. Right, and so what is a movement grid going to need? It's going to need a list of vertices. Now the question is, do we generate a grid of the entire scene per frame, which I don't think is the right move, or do we generate one of these grids per unit, but only when the unit requests a move? Because I feel like if we did the entire scene, and the scene is rather large, like that would be an unnecessary amount of work. What I meant is that you should expect that moving to 100, 100 would have a distance of square root of 100 plus squared plus 100 squared equals 141. But here it would be 100 plus 100 equals 200. I feel it may be unnatural unless the system is only for movement check and not for actual movement. Yeah, so the system that determines whether you can move So that kind of goes back to what I was saying is this system basically says where you are on the grid and where you're going to, but it does not represent the time or your actual, how long it takes to get from A to B. The movement speed is the movement speed, and that's outside of this grid. It's not represented by this. So the grid doesn't actually control that. All it does is say, we have this collection of vertices. They have these various properties of, here's what its height is. Here's what its flags are. So whether it's traversable or not, or what kind of things can traverse over it. And then, yeah, that's pretty much it. Can we move to the next one? Yeah, if that makes sense. So this is basically just determining movement. It doesn't necessarily do anything aside from that. Will enemy collision be handled by this? Yeah, so enemies will also use this to navigate. And that's kind of where I'm hemming and hawing at the moment over, do I just want to generate the entire thing? Because enemies are going to have a way to pathfind and be able to get to you from somewhere. So, I guess the simplest example for that might be something like, and I'm going to do this minus the grid, right? This is just going to be, let's say we have a scene, right? And there is a cliff, right? So there's everything up here is sort of higher land, and everything down here is lower land, and then everything here is an impassable wall, right? So all of this is just an impassable wall. But maybe down this way, there's more cliff that goes off this way, whatever. But there is a path or a break in that, right? That allows you to go, use the other mouse, that allows you to go this way, right? And so if we had the player is down here. If the player is down here and the enemy was, say, here. And then let's say there was some other stuff in between that was also impassable, right? So, I don't know, some random stuff, whatever, right? So basically this whole area is just not passable. And I know this is a super, super shitty drawing, but I think you guys get the point. Basically, this player is going to, or the enemy rather, to get to you, right? Because he looks across here and he sees you. He's like, okay, you're within range. I can see you, but I can't get to you to actually physically attack you. So he's going to have to do something like go this way and then go up around this way and then around this way and then come down here, come here, and then attack you, right? So in order to have this pathfinding kind of capability, I am going to have enough grid space between, to basically figure out all the way over here and around, which is a lot more than the typical area that I would scan every single frame, which would probably be somewhere around that size, right? So it'd be that size for the enemy, and the grid would be that size for the player, something like that, right? And so really, I would actually need a grid that would be like that size or larger, right? Or if the entry point was all the way over here somewhere, and he had to go all the way over here and back around this way, right? I'd have to have an even bigger grid for that, and how to try and like figure out how big that needs to be would be a little bit of a challenge, right? Or do I put limits on it, right? Where I say, well, if I get out to this far and I haven't found any resolution, just give up. Which seems kind of poopy. Can you collide with them? So there won't be any collision at all with this. So let me just get rid of all this terribleness here. So if you are, and this is kind of what this bit was illustrating. So the how did I have this grouped before? So the brown ones here are the players, right? So if you are, if you're here, let's say the player is here. I'll just mark this, I guess, as blue, right? And you have an NPC that's here. Then you can actually pass straight through to this point through the NPC and you'll be fine. However, if this is an enemy, right, and you're trying to traverse this way, you're not going to be able to do that, right? Because you can't walk through the enemy. You'll have to go up and around. So there won't be any collision per se. We'll basically look at the grid and we'll say, oh, there's an enemy at that spot. So I can't walk this way. I would have to walk around to get over here. So there's no collision other than that, right? So it's just kind of a grid state that tells you where they are, but it's not really collision, right? I hope that makes sense. Okay, so I'm going to have to think about that grid. Like, do we do the entire thing? I'll have to think about that offline. And we'll come back to that, I think, next week. So I'm going to start thinking about some of the structures that we need to have for this system so that we can actually get this up and running as soon as possible, and then start to actually use it. Can enemies update the grid? Yeah, so the enemies would be represented on the grid, yes. Yep. Box 2D/3D. I see Neovim and a beard, so already I know this guy means business. Yeah. That's funny. You can do per tile grid cells and check when in a tile, those grid cells only. Yes. But again, if we have the problem of a cliff where there's an enemy on a higher ledge and you're down here and he sees you from the higher ledge, but he's got to go 100 yards that way to get to the stairs, to get down, to come back at you. Like, how far do I want to resolve that? And do I just keep expanding out, or do I just try to pre-generate the whole thing, and then anytime something in the scene changes, regenerate the grid, which could take a long time in theory for the whole level. I don't actually know how long it's going to take. This is part of the problem. So I guess we could probably run metrics on that, right? So in the example of this, in the example of this, we actually have, so this grid, this sort of debug grid that's here in the center, is 100 squares in each direction, right? So this is a 200 by 200 grid, centered along 0, 0, 0. As you can see, the terrain goes out quite a bit further than that. I think, was it 4 times that or something? And so even if we were to lock the points of our movement grid to 1 unit, which is essentially what this debug grid is, that's a hell of a lot of vertices, right? To generate. I guess we wouldn't generate them. We would just really be updating them. We would load up the array whenever you load up the scene, and then you would basically just update the state of each one of them as you go. The thing is I don't know how long that's going to take. I guess we could figure out how long it would take to update that many. And I can't even fathom the number of how many that's going to be in my head right now, but it seems huge. And it seems a little bit... It seems like it's going to be a little bit much. Unless we sort of also say, you know, from this perspective, like the scene doesn't need to be that big, right? I think I timed it out, and at the player's movement speed, it takes like 2 minutes to go from this edge of the map to this edge of the map. Which seems kind of large for a single area, right? And we're going to have multiple zones. So I really don't know how big we're going to have to make these zones to actually make them the way that we need them for the game. So there's a lot of questions for sure. Common thing is in RTS is that they have a lot of problems with pathfinding. When units block the pathfinding of other units, it's a hard problem to solve. Yeah, so enemies won't be blocking other enemies. And that is going to be an interesting thing that we're going to have to solve as well, come to think of it. If we have a lot of enemies on the screen, we are going to have to do some problem-solving stuff. Because we'll have to have a situation where I'll just use this corner up here. So, you know, if we have 5 enemies, right, for example, and we say we all want them to be based around where... Let me clean this grid up a little bit. Actually, let's go down here. So let's say we're here, right? And we actually have a bunch of enemies that we want to appear around the player trying to attack them, right? So we could very easily pick the 4 closest points and surround them this way. That's fairly easy, right? And then the next 4 around that would be easier, right? Because these would be the next 4 points. But then after that, what do you do if you have more enemies than that, right? You don't want to stack the enemies. The enemies should be able to go through one another, but they shouldn't be able to stand on the same tile, or the same vertex. So you'd then have to start branching out this way to get the next closest points, right? And then just keep circling around that way. So I don't know exactly how that's going to work yet. And I also don't know if we're actually going to wind up having that many enemies at once. I haven't really decided that yet. So that is something we're going to have to think about for sure. Can do per tile grid cells and check when a tile is in those grid cells only. I understand the issue now. Curious how you're going to solve it. So I haven't done any nav mesh at all yet. Yeah, so that's going to be the thing, right? We're going to try this system and see how it works. There's also the possibility that maybe we have, and I mean, if this grid is at high enough resolution, a solution like this will be fine, right? Because this won't look too terribly strange, right? At a high enough resolution, I think. If not, then maybe the enemies will use this kind of thing to kind of pathfind their way to you, but then maybe once they get close enough to you, they can break off the grid and do this kind of movement, right? So I don't know. We'll have to kind of experiment around with that and see how that works. All right. With all of that said, I think I'm going to call it for tonight because I'm pretty tired. Obviously, I've got some thinking to do, but I really like kind of the way that this system is going to work. I think this is what I'm going to go with. It makes the most sense to me, and we're going to try it and see how it works. I think you could use a sparse grid and allow the units to be in any interpolation inside that grid. That's kind of, I guess, what I'm saying here, right? So we're gonna have to try a few things, like maybe they stick to the grid to get close to you, and then once they get close to you, if they're within a certain radius, they're allowed to sort of break form a little bit. Okay, let's see who's available to raid. And while I'm looking, I do want to just say a big thank you to you guys again who have joined tonight and interacted. It's been kind of an interesting session. Didn't do really any coding, but sometimes you kind of have to step back from the coding and kind of think about the actual problem that you have, and think about how you want to solve it before you really start writing code, right? Because the last thing we want to do is throw away too many systems, right? So let's see. Hoping to be able to find somebody that's kind of doing something similar to what we're doing. I don't know if we're going to find that or not. We have mixed luck with that. Let's see. All right, I see somebody that we could go ahead and raid. I think that's what we'll do. We're going to check out... Oh, and he's only been up... Wait, is that 45 seconds or is that 45 minutes? I don't know. We'll check it out. We're going to raid Moonwood Games. And actually, I'm going to hook up the YouTube side to do this as well, if I can remember how to do it. Because I do know that he streams on both. He is making a roguelike that uses blackjack as its combat mechanic. It's pretty cool stuff. So, let me just set up the YouTube side as well, if I can remember where that is. Here we go. And there we are. Okay. All right. yeah, we're gonna go check out his stream, see what he's up to, and yeah, we'll catch you guys in the next stream. Thank you guys so much for being here. I appreciate you guys, and yeah, we'll start building out this system in the next stream. See you guys. Have a good one.